Got a bit of yapping to do, as much as I don't like to do that. So, what chapter is this called? Quadratics. There is a quadratic function because it's got an f of x in front. There is a quadratic equation. What's the difference? Not a heck of a lot. And if it's an x-intercept of a graph, of course, that was yesterday's stuff, right? All the same. What makes this thing quadratic, though? Yeah. Our most basic go-to quadratic is that if b is 0, if c is 0, and if a is 1, that's what it looks like. Okay? It's your most basic quadratic. This whole lesson, we're going to compare quadratics to that. We're going to analyze them. And this is in 2 parts. Okay, so part 1. So that is quadratic, and the reason it makes this shape, the reason it is quadratic is because of that little power of 2. Okay? So you didn't get that in grade 10. This is grade 11 stuff. And this is to make the professors happy. Of course, you know, A, B, and C are, what's this say again? You guys remember? This is Greek letter epsilon standing for, in this part of math, belongs to the set of. And R stands for real numbers. Okay, we're going to actually say those words you didn't like in grade 10 in a few minutes, domain and range. And of course, A can't be 0, because if A is 0, you don't have an x squared, and therefore you don't have a quadratic, and it makes no sense. You don't have one. Okay? They're calling this general form in this textbook, if it's a function, or if it's an equation. And they're calling this standard form, which I like to call Vertex form. And you'll see why in a few lessons, why that's a better word for it, okay? Because I've seen some other textbooks, they mix these up, and they call that standard form, and they call this Vertex form, and it doesn't really matter, okay? But that's quadratic. This is quadratic. When you guys did that worksheet yesterday, that was the form I gave it to you in. We'll see how much that was absorbed and how much easy today's lesson will be because of that, okay? So, analyzing the graph. This is your go-to standard y equals x squared. You got this on the project, which should be getting handed in. And if you don't know how to graph this, you can always make a table. If you don't have technology, here's where you want to start. If x is 0, 0 squared, you get 0. Okay? If x is 1, 1 squared, you get 1 for y. If it's negative 1, use brackets when you substitute. That's negative 1 squared, which is negative 1 times negative 1, which is positive 1. Okay? And then, you know, 2 is 4 when I square it. 3 is 9 when I square it. And vice versa for the negatives. They become positive. What some of you guys did on that handout was just stop there. But, I mean, could I put a point, another one, x here for 4? Could I put one here for 11? Could I put one here for 19? Could I put a point 33? Does this graph stop right here? No. That's why I said, do that. Great. Do the fun stuff. Connect the dots. But I said this. Extend it beyond the graph and put arrowheads there. Because this graph doesn't stop. It keeps going forever and ever and ever and ever. Could I use a value of x 100 and square that and get the value of y? Yes. Okay, that's way, way, way beyond this graph, but it doesn't stop here. It keeps going forever. So put arrowheads there. So, everything we do today, we're going to be comparing to that. So stick that in your memory bank. Take a visual of it. That's y equals x squared. Okay, when I say y equals x squared, you should see this picture. You should know what this thing looks like. Okay, a little bit of biology. Axis of symmetry. What's the word symmetry mean to you? Yeah, Well, where is a line that we will consider as our mirror line for that picture? Where does the left side look like the right side? If I do that, does that look symmetrical? Does the left side look like the right side? Yeah, that is an equation for a line. That happens to be our y-axis for this one, okay, but it's not always, of course. I can have a parabola way over here, okay? It still has an axis of symmetry. These are always in the form x is something. Because the only parabolas you're going to get in grade 11, they're going to look like that, or they're going to look like this, okay? They're not going to be any on their side. So every one, this has an axis of symmetry. That's where the left side looks like the right side. And I don't know where this thing is in space, but it has an equation. X is something. So what is x here? Every single one of those points, the x value is the same. It's 0, right? So for this guy, that's the equation for the axis of symmetry. X is 0. Okay? Make sense? More wordage. Vertex. What's the vertex? Well, let's read it. It's where the axis of symmetry is, where it intersects the parabola. The vertex is either a minimum or it's a maximum. Here, the lowest point on this graph is a minimum. So right there, that's where the vertex is. What are the coordinates of this vertex? Yeah, right there. Okay? So label the vertex on this graph, V, and state its coordinates, means x and y. So when you write a coordinate pair, of course, it's in brackets. You got a comma between x and y. Okay? That's got a minimum. This parabola has a maximum, however. So wherever this guy is, that's its vertex. Okay? It has a maximum. See the difference? Either they're going to, well, here's the wordage, they're either going to open up, like this one, and therefore they have a minimum, or they open down. I don't know what kind of way you've described that on the project, but if it would made sense, then you got a mark for it, right? Okay. All right, let's go over this. What is domain? You loved this in grade 10, didn't you? Domain and range. You got a 50-50 chance. Is domain X or is it Y? Many of you remember. It's X. So the range is Y. So when we say what is the domain, we mean what are the X values of this graph. So these are all X values of the graph, -3, -2, -1. But if I look at -3 there and -2 there, every point in between, this one, this one, this one, this one, this one, how many points are there between -2 and -3? Infinitely many. Obviously, I'm not going to list them all. This is what we call continuous data, right? Okay, it's like time. You can slice a second into half a second, quarter second, a tenth of a second, hundredth, a thousandth, a millionth of a second. It's continuous. So it's all these points. How far left does this go? Okay, like ask yourself, here's the equation. Can you put x -1,000 in here and find out the value of y? Sure you can. I could put in -1,000,000. There is no limit to how far left this thing goes. So yes, it goes up, but it also keeps going out forever and ever and ever, all the way to -infinity. Okay? So how far right does it go? Positive infinity. Keeps going up and up, but also out forever and ever and ever. Okay? So the x values of this graph are everything from -infinity, all of these points, all the way out to positive infinity. But that's in English. So how do I say in math every single x value you can think of? How do you write that? X is the set of all real numbers. No restrictions. Okay? Everything. That's how you write that in math. Okay? Ring a bell? Range. Is range all real? It is from here up. Okay? It goes up to positive infinity, but it doesn't go down here. What's the lowest point? Remember, I have a minimum. Okay, so it only goes down to the vertex, which is, when you're looking at range, okay, your eyes just go vertically. Don't look horizontally, right? So it's from this point up. So in English, the range is every single point for y from this point up. What's this point for y? 0. So in other words, it's everything above and including 0. That's English. How do I make it math? All the values of y greater than and including greater than or equal to 0. But to make all the professors happy, we also have to add this, okay? It is all the real numbers from 0 and up. Because you could have a graph like that. It's just whole numbers or just natural numbers, right? This is continuous. So I have to write that. Okay, but this is the important part. All right? All right. Now, let's get to the real stuff for this lesson. Here is vertex form of a parabola, of a quadratic. Today we're going to play around with P and Q. Tomorrow we're going to see what A does. So everything today, A is going to be 1. In other words, you can just drop it, ignore A. Okay? So what does P and Q do? P and Q do. This is what we're going to do. We're going to play around, investigate, analyze. These are called transformations. We want to always compare our most basic y equals x squared. There it is, okay? So 0, 0, 1's 1, negative 1's 1, 2's 4, okay? And again, you only have to do one side because this thing's symmetrical. You can just copy it to the other side. Now you know that. So, don't really like this too much. All this says is y is x squared, f of x, and then I'm going to add 3. So, I got you to do that on that handout. Did it stick in your head? I know you all got the right answer when you handed it in. Do you know what that does yet? Let's find out quickly. Let's make a little table, okay? But we don't want to graph every one of these. We want to get to the point where we're going to look at this and know exactly what it's going to look like. What shape? Where is it? So what are some nice points I can use here? How about just negative 1, 0, and 1? Let's see what that gives me, okay? So negative 1 squared is negative 1 times negative 1 is 1 and 3. That's 4. 0 is nice. 0 and 3 is 3. 1 squared is 1 and 3 is 4. So let's plot that. Negative 1 is 1, 2, 3, 4. 0 is 3. 1 is 4. Is that enough to know what this thing looks like? I think so, right? I got this. I think it's going to look like that. Don't believe me? Plot a few more points of your own. So, what did this do? This is Q. When you plus 3 to the graph, what happens? What did it do? Ashley? Goes up 3. Every single point on this graph is now 3 units higher. Okay? So then, let's go out on a limb here And let's guess, let's make a conjecture, if you will. X squared minus 3, what's that going to do? Go down 3 units, yes. So here's where the vertex is, 0, 0. That's always a nice point to start. This one's now going to be just 3 units lower. This point is going to be 3 units lower. This one's going to be 3 units lower. Exact same shape. Okay? Exact same quadratic, just moved down 3 units. But do we have a new word for that? Hold that thought. Hold that thought. Okay? That's what this guy looks like. Okay, so what does Q do? Let's fill in this. So y is x squared. When we added 3, what happened to my vertex? Well, it went up 3 points. Every point did. So my vertex is now 0, 3 from 0, 0. I still have a minimum for this graph, but its value now is not 0. It only goes down to 3 for y, right? That's the lowest point on this blue graph. And moving it up or down, how does that change my axis of symmetry? It doesn't do anything to the axis of symmetry, right? If you go up or down, it just stays the same. So x is still 0, but here is what we're going to call this thing. So our basic y equals x squared, of course, there's no transformation. How would I describe this? They have this word, translation, okay? Got translated. So up or down, there's another word for that. What is it? Starts with a V. Vertical. This is a vertical translation of 3 units up. And if I minus 3, then my vertex goes down 3 units. Still have a minimum, but now it's at negative 3. Axis of symmetry doesn't change. How would I describe the translation? It's still vertical, but it is now 3 units down. Okay? So like I said, you got that answer on that handout I gave you, but did it stick in here yet? We need to know this. So, summary, what's the whole point? What does Q do to a quadratic? When you add some number at the end of this, Q makes the quadratic go up Q units if positive, or down Q units if negative. Okay? And they have a bunch of blanks here, which basically will summarize to the same thing. Okay? We're half done. That was Q. Now we're going to look at P. Again, we're going to compare it to our most basic quadratic, y equals x squared. So visually, how would you describe P versus Q? This was Q, right? This is P. How would you describe it? One's in the brackets, one's outside the brackets, right? Yeah? Okay. And it did say that in that handout I gave you. So let's see what this does. I'm going to pick a couple of points. What would be a really nice point here? -3? Yes? Okay, let's plot that quickly. -3 and 3 is 0. Squared is 0. Nice. -1, 2, 3, and 0. What other point might help me? Maybe one left of that, -4. So if I plug that in, I get -4 and 3, which is -1 squared is +1. And if I go one right of that, -2, -2 and 3 is 1 squared is 1. See where this parabola is? So what happened to that guy? Let's actually fill this in the table first before I do the other one. So if I have y is x plus 3 squared, what happened with my vertex? It went left. So my vertex now is -3, 0. Okay? Still has a minimum. If I move it left, does that change the minimum value? No, it didn't at all, right? So it's still at 0. Did that change my axis of symmetry? Yes, it definitely did. Now it's there. How do you write the axis of symmetry? As an equation, x equals, where is it? Yeah, as a little hint, see this vertex? X coordinate? That's where it's always going to be. Said that in the notes, but might as well say it again. And this is not a vertical translation, it is horizontal, yes. How far? 3 units. Which way? Left. Now, I want to emphasize that. Does that look a little different than what happened with Q? Left. What do you see here? Is that kind of like opposite of what you'd expect? Yeah, right? So however you want to make sense of that, okay, stick it in your head. We don't want to graph every single one of these every time. You got to know if you see +3, that means 3 units in the negative x direction, yes? Okay, 3 units left. Okay, next one. This is, now I want to subtract 3 from x in the brackets, that is p. So, because it says -3, what direction is it going to go? Yeah, to the right. 1, 2, 3. There, there, there. And that's what that guy's going to do. So exactly the same thing, just the other direction. Y is x minus 3 squared. My vertex now is +3, 0. Minimum still. Value didn't change for y. Axis of symmetry now is over to the right. And this is a horizontal translation, which is a form of a transformation. Now, there's a lot of big words here. 3 units right. Okay? So in general, whatever P does, it moves it left or right. If you see a minus, you move it right. If you see a plus, you move it left. So what does P do? Horizontal translation. P units right or left. Now I don't know if I should write this here, so I won't, because it kind of confused some of the other kids. Okay? So I'll just kind of glance over that. All right? Okay. Let's put it all together, both things. We saw what P did. We saw what Q did. So if you saw that, which is y equals x plus 2 squared minus 4, always compared to our most basic quadratic, how would you describe the movement? The transformations. Let's do the easy one first. What's this minus 4 going to do? Okay, yeah, that's Q. That is, well, 4 down, but let's use some bigger Math 11 language. That is a vertical translation 4 units down. And the one that's a little trickier, what does plus 2 do? Horizontal, that's P, 2 units, which way? Left, yeah, okay. It's kind of like the opposite thing going on there. All right. Now that, of course, moves your vertex. I'll also fill in this graph here. Y is x plus 2 squared minus 4. So your vertex was 0, 0, but if it went down 4, now it's 0, 4. If it went 2 left, it's minus 2, 4. Minus 2, minus 4? Did I say positive 4? Okay. And if it helps, you're allowed to plot it, right? Down 4, over 2, now you're over there. What's the coordinates of that thing? Minus 2, minus 4. Okay? If it helps, do it. So this thing still has a minimum. It still opens up, even though it moved over from there to there. Okay, but now the minimum value is, look at the y coordinate for your vertex. Negative 4, and for an axis of symmetry, x is, look at the x coordinate of your vertex, negative 2, and we already said this right there, so I'm not going to write it again. Okay, couple questions, examples. How would you describe that? We're going to give you the equation and you're going to have to put it in English, and then of course we're going to give you the opposite in a sec. So what does this thing do? It's 10 units, but it's horizontal, vertical. Is that P or is that Q? That's P. It's inside the brackets. If you like, that's what Q is, plus 0. Okay? You don't have to write it. So that is, I'm going to be a little lazy. Horizontal translation, HT. 10 units, which way? Left. X squared plus 4, is this P or Q? That's P. So that is a vertical translation for units, up or down? Up. Because if it says plus for Q, it's in the same direction, positive Y direction. C. What do I do with that thing? This is vertex form. I want them all to look like that. Okay? A's 1, so it's not really there. But what do I do with this plus 8? get it over there where it's supposed to be, because that's actually Q, okay? I don't want it to look like this. I want it to look like that. So this is the same as this. Now I can clearly see A is 1, P is 5, and Q is minus 8. So, do the easy one first. Minus 8, that's a vertical translation. 8 units down. And what does this 5 do? Horizontal, which way? Right, because it's a minus. Okay? 2 more. All right. So compared to that, what does that do? How do I write it as an equation? Now we're giving you the language, the English, and we're writing the equation. So y equals x squared is your basic one, but if I move it 5 units right, what would the equation be? Is that in the brackets or is that outside the brackets at the end? That's in the brackets. That's P. That's horizontal. So do I want a plus 5 or a minus 5? Opposite, right? 5 units right, that's a positive x direction, so I want it to be negative 5. Okay, and this one I got both of them. Y is x something. Let's do the easy one first. 4, oh, that's not it. This is the easy one. 6 units down. That's Q, minus 6. 4 units left. Is that plus or negative? Plus. Okay, we get it? Let me just check that, because I can, but you guys can't. X plus 4 squared minus 6, minus 6, compared to y equals x squared, did that go 6 units down? Is it 4 units left? Okay. Is your vertex now not 0, 0, but negative 4, negative 6? Okay, yeah. Okay, plotting that by hand, of course, that would take you about, I don't know how long. How quick are you? 5 minutes? 7 minutes? Okay, last one. Here's a point, but that's on that graph. When I take that point on this graph, right, 3 squared is 9. When I take that, move it 2 units up and 7 units right, what are the new coordinates? Picture might help. 3, 9. There it is. Okay? So if I go 2 units up, does that affect x or does that affect y? Well, I know it goes here, 2 units up. That doesn't affect x. That was 3, 9, so now it's still 3, but now it's 11, right? And then I want to go 7 units right. Does that affect x or y? That affects x. So 7 units right, it's not 3, 11, it's 1, 2, 3, 4, 5, 6, 7. What's 7 and 3? Yeah, okay. If that helps, do a little picture. I recommend it, but some of you will just try to do it in your head and maybe make a mistake. That's the new coordinates. Of course, every point on that parabola will go 2 units up and 7 units right, but they just want to know about this guy, okay? All right, that's it. Part 1, tomorrow we're going to add all this on top of seeing what A does.